Applications to solving rational equations. This is our very first problem. I'm going to read it out loud, and as I read it, I want you to write down the minimum amount that you believe is key information from this problem. So I do not want you to write down word for word. You are only going to pick out what you think is key information and write it down. Begin. Ian can rake a lawn and bag the leaves in 3 hours. Kylie can rake the same lawn and bag the leaves in 260 minutes. Working together, how long would it take them to rake the lawn and bag the leaves together? Okay, so this is similar, although it wasn't recorded, to the problem where we talked about a big sister and a little sister cleaning a room. So how I want you to start this problem is that we're going to identify Ian. So I got to be able to, right there. I'm going to do a minimal here. I'm going to say Ian. Okay, Ian is 3 hours for that one task. Kylie is 260 minutes for the same task. Now, I need to ensure that I'm using the exact same units, but I have a choice. I can either make them both into minutes or both into hours. There's no wrong answer for this particular problem. I definitely think that this problem, it'd be our advantage to quickly put 3 hours into minutes because I know 1 hour is 60 minutes. 60 plus 60 plus 60 is equivalent to 180 minutes. 180 minutes. Okay, so now it's time to actually come up with this equation. So the first step you're going to do in doing these problems is read the problem, and you're going to extrapolate the important information, and now we're going to write down an equation. So it's one task. We know that's raking leaves and bagging them up. I'm going to do Ian first. So over 180 plus Kylie can do that same task in 260 minutes. And this problem says, how long will it take if they work together? That's as much math as you need to do. What I want you to recognize before we go any further, before you plug anything into a calculator, all eyes up here, notice there's only one thing on top and one thing on the bottom of all of these. It makes it much easier to plug in. If there was more than one thing, which we'll see in future problems, we'd want to definitely put parentheses around that. So I'm going to switch at this time, and I'm going to come over here, and I'm going to pull up the screen so we can do this together. On your own, please do second plus 7, 1, 2. And then we are going to go to y equals, and everything to the left of the equal sign we're going to plug in. So you correct me if I choose the wrong numbers here. 1 over 180, Ian, plus 1 over 260, Kylie. Now I go to y sub 2. This will be the information on the right side, which would be 1 over x. Now don't press graph. After we plug this in, we're going to go up to Windows. So after you get done plugging this in, please go up to Windows. Ian on his own, 180. Kylie on her own, 260. I know working together, they're definitely going to be underneath 180. So I'm going to go up to Windows, and I'm going to go between 0 to 180. Then I'm going to do Zoom Fit. And I want to know, where does the blue function and the red function, represented by what we typed in, where do they cross? It looks like they cross right about here. So we're going to use, on our calculator, we're going to use underneath trace. So we're going to go second trace, and we're going to calculate where they intersect. Second trace, intersect. And it's already in that region. So I'm welcome just to go to enter and press enter 3 times in this specific situation. So I'm going to go enter, 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 and there's our answer. It will take them approximately 106 minutes working together. And now this is the last thing you need to do. You need to answer the questions in terms of a complete sentence on your paper. So I will help you with the first one. Working together, Ian and Kylie, so you should be writing this down. Working together, Ian and Kylie can rake the leaves and bag them in approximately 106 minutes. Working together, Ian and Kylie can rake the leaves and bag them in approximately 106 minutes. So on to our next question. Here it is. Again, I want you to pull out the most important information as I read it. I do not want you writing word for word. what I read. 2 different water hoses are being used to fill a small pond. So this is the small pond off to the right. It's a small fish pond, and it's empty, okay? They're going to fill it up using water hoses. Used together, the 2 water hoses can fill the small fish pond in 12 minutes. If only one is used, the shorter of the 2 water hoses is able to fill the fish pond in 10 minutes faster than the other water hose. How long does it take each water hose to fill the small fish pond? Okay, so let's give an example here. Let's get something. Let's pretend really quickly your desk, okay? I know this sounds silly, but both my first hour and my second hour really struggled with this problem. Your desk right now, your desktop is a small fish pond, okay? This sounds silly. Put your pencil or pen down. Take your both hands. Have one arm extended more than the other. Okay, now face your desk. Cool. So we are representing a longer of the 2 hoses and a shorter of 2 hoses. Does that make sense to you? If they both are releasing water into the pond, into this empty pond, how long will it take to fill up this pond working together? Read the question. 12 minutes. So on your paper, you should have together 12 minutes. Because if they're working together, they can fill this up in 12 minutes. They're both hoses are releasing water into the small pond at the same time, and they're able to fill up the small pond in 12 minutes. Now we're going to come up with 2 different scenarios. Let's pretend the small fish pond is empty, and now we're only going to put in one of the 2. So it's either the smaller one or the longer one. Which one appears after reading this to be able to fill up the pond faster? It says the shorter one. How much faster? 10 what? 10 minutes faster. Okay, so we have 2 different items here. So I'm going to say this. Oops, so sorry. Well, I can do it right on this screen. We have the smaller of the 2 hoses, and we have the longer of the 2 hoses, and then we have working together. And you're welcome just to use capital letters of S, L, and T. Okay, so 1 over whatever the smaller hose can do, 1 over the longer hose, and then together, we've already decided they can do it together in 12 minutes. So this goes back to like running that mile that's not on this particular recording, but we talked about Melissa and I running the mile and how if she can do it if she can do it in 7 minutes and I can do it in 14, it's like 2 times X. Or we talked about the young man who can run the mile in 8 minutes. Somebody else can run it in 10 minutes. It's like X plus 2. Okay, the same concept here. So let's go back and look. The smaller hose can fill the pond 10 minutes faster. So let's put an X. There's 2 different ways we could do this, but let's put an X on the longer one. Whatever the longer hose can do, I know the smaller hose can complete that same task 10 minutes long or 10 minutes shorter. So 10 minutes shorter for the smaller hose. And I always suggest coming up with arbitrary numbers. So I'm going to make these, I'm going to make up, give me 1 second. Were you able to do it, guys? Awesome. You can put it right on my desk. I'm going to make up this. So I'm going to say longer hose, completely making this up. If I say this task could be done in 50 minutes, how long would it take the smaller hose to complete the same task? A little bit louder. What would it be? 40, because 50 minus 10 is 40. Okay, we understand the concept right now, right? We understand the concept. So I have my equation here. This is always addition in between. But here's the difference between our first example and the second example. Please put parentheses around this bottom because there's more than one item there. So I don't want you working ahead here. Make sure you have this equation down before I remove this from the screen. 1 over x minus 10 plus 1 over x equals 1 over 12. Okay, now we're going to move to plugging this in. So please go ahead for me, and I would like you to do second plus 712. I've cleared the RAM. I want you to go to y equals. Okay, in the first one, I'm going to do 1 divided by, but I'm not going to type in x minus 10. I need to put an extra parenthesis around the denominator of that fraction because it has more than one item. Plus 1 divided by x. Now, on the right-hand side of the equal sign, it was 1 divided by 12, I believe. Let's go back up to Windows now. Don't hit Graph. Please go to Windows is next. Please hit Windows 1 second. Hello. Yes, I do. Thank you. Okay, you ready? Come up here. So we want to talk about how long is it going to take for the shorter hose and the longer hose to fill up the pond by themselves. Well, we know if both hoses are going into the pond, how fast does it take? 12. So if only one hose is going in at a time, and it's going to fill up the whole pond by itself, will one of those hoses take more than 12 minutes or less than 12 minutes? Talk to your partner, go. Will one hose by itself take more or less than 12 minutes? The answer is more. The answer is more. So let's go 12 here, and I'm just going to make up a larger number like 40. Okay, now we're going to do zoom fit. After we do 12, and I just made up a larger arbitrary number, we're going to do zoom fit. We're taking the two functions represented by different colors, and it looks like they cross one time. I would like you to solve that right now. Solve to find out second trace intersect. Where do they intersect? I got an answer of 30. I've got an answer of 30. Can you do me a favor, because you're going to have to do this on your own in the next few minutes. Raise your hand if you're able to achieve 30 on your calculator. Hands up high. Make sure everybody around you is able to achieve that as well. And we're going to come back up to this problem. And here's the reason why I wish I would have not erased this. This was 1 over x minus 10. This was 1 over x. This is 1 over 12. This was the smaller hose. This was the larger hose. Okay, so I got an answer of 30, and now I have to write a complete sentence that answers the question, which is how long does it take each hose to fill up the small pond? So it's 30 is equal to x. That means this one task, the larger hose, or the longer hose, I should say, can fill up the pond in 30 minutes. 30 minus 10 is 20. The shorter hose or smaller hose can fill up the pond in 20 minutes. You need to write a complete sentence answering how long does it take each water hose to fill the small fish pond. Working together, Anaya and Bill stained a large porch deck in 8 hours. So together they can do it in 8 hours. Oops, oh my goodness. Together they can do it in 8 hours. Let me get this. Together 8 hours. Last year, Anaya stained the deck by herself. The year before, Bill stained the deck by himself, but it took him twice as long as Anaya. How long did Anaya and Bill take to paint the larger deck? So remember, Bill is twice as slow. So I'm going to put down Anaya, Bill, and together. You want to be able to label what things are. So we have one task for each. We know together they can do it in 8 hours. Now, what do we know about Bill? It takes him twice as long. So I'm going to put down an X for Anaya and 2X for Bill. And then I always suggest you just come up with some arbitrary number to make sense of it. I'll give you an example. If it took Anaya 10 hours, we know it takes twice as long for Bill, so it takes 20 hours for Bill. And this expression makes sense because 10, we double it, we get 20. This is what I'm plugging in, but when you plug it in, it's important to double parenthesis this bottom, okay? So I'm going to go right now. I'm going to do second plus 712. Second plus 712 coming up to y equals. And I have 1, I'm forgetting what it was, 1 divided by x plus 1 divided by, now I need a double parenthesis because there's more than one item, and 1 divided by 8. Okay, so if together they can complete the task of staining the deck in 8 hours, I know individually it's going to be more than 8 hours. So I'm going to start at 8, and I'm going to go out somewhere beyond that. Like, it's always better to go with a larger number. And then I'm going to do zoom fit, which is zoom 0. I want to know where do the two functions that I've created intersect. Here's where they intersect. Second trace intersect. This is the answer. It's 12. But that still doesn't answer it for me. I need to come back to what I did. So this is what I had. And I got an answer of 12. So when I write down the complete sentence, I would say, we can anticipate it'll take 12 hours for Anaya to stay in the deck by herself, and it would take 24 hours for Bill to complete the same task. Something like that. Okay, we are coming on to a new problem here. So this is the second type of problem that we're going to do. And there's a few terms here that we need to review. The first one, turn to your partner. You have 5 seconds to answer this question. Don't worry about reading this right now. I just simply want to know, what does the word consecutive mean? Tell your partner, what does consecutive mean? Oh, I like it. That's good. I heard somebody say like in a row or repeating or back to back, right? So if somebody says to you, Miss Bradley gave you a multiple choice quiz. Is everybody listening? And after problem 4, you got every consecutive problem right. So you got the problem 4, and Miss Bradley hasn't told you the final result, but she's like, hey, after 4, you got every consecutive problem correct. What would that mean? Turn to your partner, go. What would that mean? You got them all right after number 4, right? 5 is right, 6 right, 7 right. Everybody got that? Okay. If somebody says that they surpass your score, what does it mean? They got a higher score. They beat your score. Okay, we need to know those key terms. Now, here's the next thing. This is me personally. I found out today this is not the norm. If you go into your current science class, I'm going to make this up, and you get back a test, and this is what it says to you. It says you have a 62 out of 78. I learned today that very few kids take time to do anything with that. As a student, I would have, or as a parent of my children, I would always go 62 divided by 78. And that means nothing to me personally until I put it into a percentage. Did anybody else like that? Anybody else put things into percentages to make more sense of them? That's what I do. Otherwise, I'm like, well, what does that mean? Okay, that means that this person got 78% right. Okay, so this is what we're going to do here. We're going to compare the results of 2 students taking a standardized test in the ACT. So the first person is Karen. So let's just put a K down. We can be minimalist here. 37 out of 50 right. But what does that mean? That means she has attempted 50 problems, and of the 50, she's got 37 right. Doesn't mean that 37 in a row, just 37 total out of 50. Please take your calculator, take 37 divided by 50, or if you know the math trick, you can just double that score of 37. What do you get? What's 37 divided by 50? Okay, so circle that. We know what Karen is at. Now we're going to compare this person to Sam. What is Sam's current rate? He has scored what? 25 of 42. So let's get a percentage for Sam. Let's find a percentage for Sam. What is Sam at? Sam is at, if I remember right, is it around 59%? Yes or no? Yes. Okay, somewhere around 59. So this is what this is saying. Whether this is realistic or not, this is what this is saying. If we stop them both from taking a test, and Karen no longer finishes the exam, she just stops where she's at. And there's an unlimited number of questions here, okay? How many would Sam have to get correct consecutively? So every problem he attempts from this point forward, he gets right. In order for his percentage to now be better than Karen's. So here's what we're going to do. Which student, which is obvious, which of the 2 students is lower? Sam, we're going to do this equation together. It's very simple. Please write 25 over 42, and I want you to extend that division sign. In order to represent that every question Sam attempts, he also gets right, I want you to put a plus X and a plus X. And I think it makes most sense to actually just draw a little diagram so kids can understand that. So right now he's only attempted 42, but if he attempts 43 questions, how many is he guaranteed under this system to get right? Not 25, but 26, because every question he attempts, he's now going to get right according to this. So if he attempts 44 questions, how many can we assume he's going to get right? 27. If he attempts 45, how many is he going to get right? You guys get that, right? The pattern, right? You add one to the top, you add one to the bottom. Now let's first just set that equal to Karen. Do we now have an equation on the left and an equation on the right? Right? Sorry, do we have an expression on the left, expression on the right? But here's where a lot of kids got this wrong earlier. How many items are on top? More than one. You got to hug the top and hug the bottom. You ready? Let's flip this over and let's answer this. So I'm going to bring this out here. And we're going to go 2nd plus 7, 1, 2. Okay, so it was hug 20, was it? Oh, I'm forgetting now. Does anybody have it down? What was it? 25 plus x divided by, I'm going to hug the bottom, 42 plus x. And now your y sub 2 will be Karen, and I'm forgetting. Was she 37 over 50? Okay, now let's go to Windows. Let's go to Windows. What did I do wrong? Thank you so much. Let's go to Windows. So we have to make common sense of this. X represents the number of questions. We know he needs to do more than 0 because by not doing anything, he hasn't beat her. So let's put down at least one question he needs to do. How many does he need to do? I'm not sure. I'm just going to guess right now, and I'm going to say, I don't know, 25. I have no idea. So let's do Zoom Fit. Zoom Fit. And if we cannot see where the two functions intersect, we can. Okay, are you ready? You have 15 seconds to find the intersection. Ready, get set, go. The question we were asked is how many questions under the scenario that everyone he answers moving forward he gets right, must he get right in order to surpass? So we set these equal to each other. I'm going to write down 23.3. Give me a second. 23.3. It's the last problem we're going to do today. So I'm going to write down, if I can grab this here, I'm writing down x equals 23.3. So we know that Sam will equal Karen if he answers 23.3 questions. By the way, can you answer only 0.3 of a multiple choice question? You either answer 23 or you answer 24. With your current partner, which one does he need to answer? 23 right to surpass or 24? Go. Is it 23 or 24? 23.3 is when they're equal. So if you go below 23.3, Sam's not going to be even equal to her. He's going to be less. If you go above 23.3, Sam has now surpassed Karen. So 24 questions Sam must answer consecutively and correctly in order to surpass Karen's score, assuming she does not continue to test.